So whatever your next page is, leave a space for it because you want to leave a space for your 2.4 conclusion questions, because when we come back to school, you'll end up getting them printed off and taped in there. So I'm going to go onto my next page and we're going to title this 3.1 Food Fiasco. And this is right off of the PLTW website, but I just printed it off just to make it a little bit easier to switch between the dot camera. And so that 3.1 Food Fiasco, and you can pause and rewind it, and you should be copying these in your engineering notebook. So looks something like this. Talks about inviting you to Dan's neighborhood party. They're going to provide hamburgers, buns, ketchup, chicken wings, hot dogs for the kids. This is the invite. And then it says, on the day of the party, the guests arrive at Dan's house and enjoy delicious food and fun with friends. The weather was sunny and warm, perfect for playing games outside. About an hour after the party, a bunch of people who attended the party showed up in urgent care with facility complaining of stomach aches and vomiting. Uh-oh, it looks like Dan's food made some of the partygoers sick. How can you figure out what food item made these people sick? How many of them are getting sick? So you already read about the epidemiologist, but now we're going to get into attack rates. So it says, when investigating disease outbreaks, epidemiologists look for patterns. They interview anyone who is sick as well as those who are not to see whether they notice a pattern in behavior. Probably the most famous epidemiologist right now is Dr. Fauci with the coronavirus, but it doesn't always just have to do with viruses. It says in epidemiology, or I should say coronaviruses, once epidemiologists have collected all of the data, they can determine the probability or likelihood of people developing an illness. They can calculate the probability using an attack rate formula. The attack rate shows the risk of an illness as a percentage. So we're going to copy this down in our notebook because you're going to need it a little bit later. So I'm going to write attack rate formula. It is the number of illness cases divided by total number of people. And we have to make it into a percent, so that's why we multiply it by 100, and that is our attack rate. And you can pause or rewind this anytime. So it says then to determine the food that is the most likely culprit for making the partygoer sick at Dan's party, epidemiologists would calculate the food-specific attack rate for each food item consumed at the party. If the attack rate for a particular item is high, then there's a high likelihood that eating it would make the person sick. So again, we're going to copy this down. So this is our food-specific attack rate formula. So we've got the number of sick people who ate a specific food item divided by the total number of people who ate a specific food item. And then we multiply it by 100 to get it in a percent, and that's our food specific attack rate. Now let's go ahead and get an example in. So it says, now if we've got this one talking about dates. Dates are a sweet fruit were served at a community picnic. Based on the data present, it was concluded that several of the people who attended the picnic became sick and an outbreak ensued. 11 people ate dates and 8 of them became sick. So if this is our example, we know that 8 people became sick after eating the dates, and there were a total of 11 people 11 people that ate dates. So we do, really it's 8 divided by 11, multiply it by 100, and then that is 0.73, but that is a total of 73%, which I would say is a pretty high percentage. So that's probably what we would call the culprit. So now we're going to get into our next scenario, where it says Dan's neighborhood party. It says, now let's look at how epidemiologists might organize the data they collect related to Dan's party. To calculate the food-specific attack rate for each item at Dan's party, you'll need to organize some of the data gathered. For example, you'll need to know the number of sick partygoers and the number of well partygoers who ate each food item. So we're going to end up creating a table that is going to have all of our different food items like this in our chart or in our notebook. So I'm going to go ahead and draw this. You can pause it right now. That would be fine. So here's kind of what my just little table set up as. All I have are the different food items, and this is in 3.1 also. So it says, through the interviews with everyone who attended the neighborhood party, it was determined that those partygoers who got sick, and so this is going to be the amount of people that we got sick. So we know 3 had a hamburger, so I'm going to fill that in as 3. 4 had a hot dog, so 4 people got sick from having a hot dog. 7 had chicken wings. 7 had buns. 6 had ketchup. 9 had potato chips. 16 had onion dip. 8 had baby carrots. And 6 had slices of apple pie. So we just kind of filled in our chart. Now we're going to go on to our next one. This is where they then said, of the interviewers that indicated who attended it that did not get sick. So we're just going to, again, fill these in. So 14 had hamburgers, 11 had hot dogs, 8 had chicken wings, 13 had buns, 14 had ketchup, 10 had potato chips, 3 had onion dip, 10 had baby carrots, and 14 had a slice of apple pie. So all we're going to do is we're going to end up kind of putting this in our category. So basically to get the total, we're just going to add them straight across. So like this is 3 plus 14 would be 17. 11 plus 4 would be 15. So I would go ahead and pause this and then finish writing on them. Hopefully yours looks something like that. You can use a calculator, that's fine, but basically all we're going to do now is we're just going to calculate our attack rate. So this was our, this divided by this, this divided by this equals our attack rate. So we're going to have, it's really 3 divided by 17. So 3 divided by 17, and then is 0.17, which we multiply it by, then we multiply it by 100, so it's really 17%. So we did this and this. So now we're going to go ahead and do the same. So this one is 4 divided by 15, and then we're going to multiply it by 100. So that's 26%. Go ahead and pause this and calculate yours out. All right, so hopefully yours looks something similar, where basically you take the sick divided by the total equal and then multiply it by 100. So again, if we're looking at the higher the percentage would probably be your likely cause. So I would pause this and go into your Google Doc, that's your assignment, and go ahead and answer those 2 questions. And I believe you're going to be inserting a picture of this as well.